Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, the official guide to the revised GRE, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problems that we are about to solve are the ones that you will find on page number 243. Please turn to it. Page 243, and today is our lesson number 347. These problems that you see there on page number 243 are the exact same problems that appeared in the first edition of the revised GRE. We have already solved every single math problem from this book. If you're interested in watching the original solutions, you will find the solutions on day number 137. Now, here's the work that I gave you yesterday as the homework. You were supposed to do it on your own, and then now we'll do it together. It's a quantitative comparison question. What is given to us is the fact that the sum of the a and b, a plus b equals 7. We are told the sum of their squares equals 40. The question simply is, how do these quantities compare? A times b versus 5. A times b versus 5. Let's see what we can do here. This quantitative comparison question obviously has to do with the three formulas that we learned yesterday. We must know those three formulas, and if you haven't watched yesterday's videos, make sure you watch yesterday's video first. You must watch these videos in sequence. Don't go all over the place. Of the three formulas that we learned yesterday, the one that we need right now is the sum of a and b, a plus b whole squared. A plus b whole squared, we know it equals to a squared plus 2ab plus b squared. And again, as I said before, during the exam, if you draw a blank and if you can't remember it, it only takes few seconds to do it out. A plus b whole squared simply means a plus b times a plus b. That's what the square means. That's what the square means. So you just do it out. A times a is a squared. A times b is going to give us ab. B times a is going to give you another ab. And b times b is going to give us b squared, which is a squared plus 2ab plus b squared. And this is something we have to know. Without this, we cannot solve this problem. So let's do it then. So we know that a squared, a plus b whole squared equals a squared plus 2ab plus b squared. A squared plus 2ab plus b squared, which obviously can be written as a squared plus b squared plus 2ab. And this is simply a plus b whole squared. All we have to do now is plug in the values and solve for a times b. A plus b we know is 7. So a plus b is 7. This is 7 squared. And this is a squared plus b squared, which we know is 40. Plus 2 times ab, which means 2 times ab is simply 49 minus 40. 49 minus 40, which is 9. If 2ab equals 9, that means ab equals 9 over 2. That's all. A times b equals 9 over 2, which is 4.5, which is less than 5. 5 is bigger, therefore the answer is b. That's all there was. Let's do problem number 3 now, okay? Let's do problem number 3. This was a bonus problem. This is not in the book. This is not in the book. This is a bonus quantitative comparison question. What I was trying to make you understand is that you have to know these three formulas because this is how they appear in the exam. And you have to be able to immediately tell which of those three formulas you need to use there, which of those three formulas apply here. Here we need a plus b whole squared. And how do we know that? Because we're given this quantity, a plus b equals 7. Let's do the next one, shall we? Number 3. We're done with this thing. I'll give you a second in case you need to pause this thing. Problem number 3 is what we have to do next. (3a). Problem number 3a. We are told that f of x equals 3x squared minus 7x plus 23. And the question simply is, what is the value of the function when x equals 2? When x equals 2, when x equals negative 2 rather, when x equals negative 2, all we have to do is go to our original function, and wherever we see x, replace it with negative 2. That's all. Wherever we see x, we replace it with negative 2. So we have 3 times negative 2 squared times 7 negative 7 times negative 2 plus 23. Negative 2 squared is 4, so this is simply 3 times 4. This negative and this negative is going to make them positive, and 7 times 2 is 14 plus 23. And that gives us 12 plus 14 plus 23. Something has gone wrong, has there? Or perhaps not. That's it. That's all. You just have to add up the 3 quantities. Just erase everything else from the last time. We don't need it. Three plus 4 is going to be 3 plus 4 is going to be 7. 7 plus 2 is 9. And then 20 plus 30 plus 40 is 49. Let's do the next one. Part B. If I can get a decent marker, that would be wonderful. Part B. Here we have another function, and they're calling this one h of x. The name of this function is h. This one was f. And we are told this is x cubed minus 2x squared plus x minus 2. And they want us to find the value of the function when x is equal to 2. When x is equal to 2. So we just go to our function, and wherever we see x, we're going to replace it with 2. That's all. So we get 2 cubed minus 2 times 2 squared plus 2 and a minus 2. Now, how much is 2 squared? 2 squared is 4. 4 times 2 is 8. So this quantity is 8 with a negative sign in front of it. So it's a negative 8. This negative 8 and this positive 8 is going to drop out. And this positive 2 and this negative 2 is going to drop out. And the answer is a big fat 0. Answer is a big fat 0. And therefore we say that h of 2 equals 0. Let's do C. We are given another function, and this time they're calling that function k. The name of this function is k. And k of x, we are told, equals 5/3 x minus 7. And the question is, what's the value of this function when x equals 0? Oh, we just replace x with 0. 5/3 times 0 minus 7. Or 0 times anything is just 0. 0 minus 7 is just minus 7. K of 0 equals negative 7. That's all. Let's move on then. Problem number 4. We are done with this thing. We move on to problem number 4. And this is something we did on day number 138. We're done with this part. I need to erase it obviously. In problem number 4, we are told that g of y equals to y over absolute value of y. That's the function. The function is you divide the value of the variable by its absolute value. And the question simply is, how much is g of 2? Again, nothing to it. We go to our original function, and wherever we see y, we're going to replace it with 2. G of 2 equals, wherever we see y, we replace with 2. So it's 2 over the absolute value of 2. Well, absolute value of 2 is 2. So it's just 2 over 2, which is just 1. Let's go to the next one, part B. Part B says g of negative 2. Again, nothing to it. We just go to our original function. Wherever we see y, we're going to replace it with negative 2. Wherever we see y, we're going to replace it with negative 2. So on the top, you're going to have negative 2 over absolute value of negative 2. But absolute value of negative 2 is going to become positive 2. So on the top, you have negative 2. Absolute value of negative 2 becomes positive 2. And negative 2 divided by positive 2 is negative 1. Let's do part C. In part C, we are being asked to find g of 2 minus g of negative 2. G of 2 minus g of negative 2. We just found out g of 2 is 1. So g of 2 is 1 minus g of negative 2. G of negative 2 we just found out is negative 2. G of negative 2 we just found out is negative 1. So it is 1 minus a negative 1. 1 minus a negative 1 gives us 2. Gives us 2. That's our answer to part C. I will see you tomorrow, where we'll continue our work on the next page. Okay? Bye now.